So this is one of the most important concepts of calculus, and what we love calculus so much for is that when we take the derivative, that is giving us the instantaneous rate of change, or just the rate of change at a particular time. And we discussed that that rate of change is also the same thing as our marginal concept. So if we're asked for marginal profit, we need to take the derivative of the profit function. So here we have a cost function, and we're asked for the marginal cost. So to find the marginal cost, we need to find C prime of t. The 140 is a standalone constant, so that will just become 0 when we take the derivative. Now, our negative 60 is a coefficient, so it tags along. And then for our e to a power, what we have to do is we have to rewrite the exponential. So we'll have e to the negative t. And then we multiply that by the derivative of the exponent. Now, negative t is raised to the first power. So when I take the derivative, because it's a linear term, I will just have negative 1 for the derivative. So this will be times negative 1. Now, if you look here, the negative 60, the negative 1, you can multiply those together to get 60 e to the negative t. And that becomes our C prime of t. Now, to finish up this question, they are asking us specifically for time is equal to 6. So what we need to do is take our marginal cost function and plug in 6. So we'll have 60 e to the negative 6. And when we when we compute that, we will get 0.148. All right, as just another quick example, sometimes we just want the marginal demand function or marginal cost function, and there's nothing to plug in. So on this question here, they give us a demand function, and then we are supposed to find the marginal demand function. So to do that, we take the derivative. The 57 tags along as a constant coefficient. And then our e to a power, we will rewrite as e to the negative 0.006p, and then multiply by the derivative of that exponent. And again, because this exponent is p to the first, that derivative will be negative 0.006. Usually what will happen is something here at the end will combine with something at the front, so we can multiply the 57 times the negative 0.006, and that will give us approximately negative 0.342 e to the negative 0.006p. And that is a perfectly acceptable answer because that represents our demand function. Actually, there's an equal to there. That represents our demand function for any price p.